Hi, Assalamualaikum warahmatullahi wabarakatuh. Hi everyone. So today we are going to enter a new chapter, which is chapter 6, chemical equilibrium. And today we are going to look at the first subtopic, which is 6.1, dynamic equilibrium. So at the end of the lesson, you should be able to explain the following terms. First one is reversible reaction, dynamic equilibrium, and law of mass action. State the characteristics of a system in equilibrium and interpret the curve of concentration of reactants and products against time for a reversible reaction. Okay, let's proceed. Okay, so basically in chemistry there are two types of chemical reaction, which is non-reversible reaction or irreversible reaction, and second one is reversible reaction. So there are only few chemical reactions that proceed in only one or non-reversible direction. For example, the CH4 plus Cl2, it just undergo the forward reaction to form CH3Cl plus HCl. So the non-reversible reaction is a reaction that proceeds in only one direction, and the reaction will stop when the reactants have completely converted into product. But most chemical reactions, they are reversible reaction, at least because when they do the chemical reaction, they can proceed in both forward and reverse reaction. For example, A can produce B and B can go back to the A, to the reactant. Okay, so let's see the term what is forward reaction, backward reaction, and reversible reaction. So forward reaction is the reaction that proceeds from left to right. So which means from reactant to product. Okay, so backward reaction is the reaction that proceeds from right to left, which means from product back into the reactant. So what is reversible reaction? So reversible reaction is a reaction which take place in both forward and reverse direction. So the reaction for reversible reaction, they proceeds in both forward and backward reaction or reverse reaction. Okay, dia ada dua lah, sama ada backward or reverse. Either one you can boleh pilih mana je yang you suka. Tapi dia bagi maksud yang sama. Backward and reverse is the same. Okay. Okay, so the arrow here. Can we do arrow here? Okay. So the arrow here, alright, dia indicates a reversible reaction. So kalau non-reversible reaction macam tadi, dia hanya ada satu arrow saja. Satu arrow macam ni je. Okay, only one arrow macam ni. However, for reversible reaction, dia ada arrow separuh ke from left to right and arrow separuh from right to left. Okay. Alright. So, in a reversible reaction, initially the reaction proceeds towards the formation of product. Okay, first, reactant will undergo forward reaction first from reactant to product. However, as soon as some product molecules are formed, the reverse process begins to take place. So, lepas reactant dah form product and after some product is formed, this product will undergo reverse reaction where it will form back into a reactant. So, a reactant molecules are formed from product molecules. Okay, so let's consider the following reversible reaction. So we have A react to form B. Okay, so the graph of the concentration of A and B against time. So in this reversible reaction, you will often see this kind of graph, concentration versus time. Okay, so in this graph, you will see that with time, the reactant A, the concentration of reactant A decreases. Okay, And then when it reach the time T1 here, it remain constant. Okay, and then for product B, with time it will increase. So this is we talk about the forward reaction. So okay, baik semula Miss terangkan. So concentration of reactant A decreases with time for forward reaction. Okay, the concentration of product B increases with time for a forward reaction. Okay, but they both remain constant at time equals to T1. Okay. Tengok. So at initial condition T dia kosong kan? T dia 0 second. Apa benda? Okay. For both of them, at initial condition T equals to 0. So yeah, concentration of A decrease with time. Concentration of B increase with time. So after time T1, concentration of A and concentration of B remains unchanged. So the system is in the state of equilibrium, dynamic equilibrium. So the moment they remain unchanged or remain constant, the moment both of the concentration A and B, oops, what happened? The moment of both concentration of A and B remain unchanged or constant, the system is in the state of equilibrium. Okay, dynamic equilibrium. Okay. Wow. Come on. Okay. Alright, sorry guys. What happened? Okay. So, the equilibrium is a dynamic equilibrium. So, means that after time T1 tu, the reaction did not stop. Okay? The reaction does not stop, but it achieved a state of chemical equilibrium which is dynamic equilibrium. Okay? So, when the reaction achieved the dynamic equilibrium, it is said that the rate of forward reaction is equal to the rate of reverse reaction. Meaning, both forward and reverse reaction are proceeding at equal rate. Okay? So, there is no net change in the concentration of A and B. Sebab apa? The rate of forward reaction from A to B is the same with the rate of reverse reaction from B to A. So, there is no change in concentration for both of them, kan? So, masing-masing sama. So, that is why kita cakap at dynamic equilibrium T1, the both forward and reverse reaction are proceeding at an equal rate. Or rate of forward reaction is equal to rate of reverse reaction. Mana-mana pun boleh. Okay? But it does not mean that the concentration of A is equal to concentration of B at equilibrium. Dia cuma cakap the rate of forward reaction is equal to rate of reverse reaction. But the concentration will not be the same lah, bukan? Because it depends on the chemical equation. It's not depends on the chemical equilibrium. Okay, the concentration of the reactant and product it depends on the chemical equation. Okay, bukan depends on equilibrium. Equilibrium cuma decide whether the rate of forward reaction is equal to the rate of reverse reaction only. Okay. So, what is equilibrium? So, equilibrium is a state in which there are no observable changes as time goes by. So, kita ada two types of equilibrium. First one is physical equilibrium and the second one is chemical equilibrium. Okay. So, what is dynamic equilibrium? So, dynamic equilibrium is when the reactant and product concentration stop changing because the forward and reverse rates have become equal. Okay, so bila the forward reaction and the reverse reaction are proceeding at equal rate, so the concentration of the reactant and product remain unchanged or remain constant. Okay. So like this lah, rate forward is equals to rate reverse. Okay, chemical equilibrium. So, most chemical reaction are reversible. Okay, like this, okay. So, if we look at this, For this reaction, N2O4 react to form NO2 gas. So NO2O4 is a colorless gas and NO2 is a brown gas. So when we introduce some N2O4 liquid into a sealed flask kept at 100 degrees Celsius, a change occurs immediately. So liquid, okay, so the liquid vaporizes because it has boiling point equals to 21 degrees Celsius and the gas begins to turn pale brown. Okay, asalnya dia colorless but then they react to form NO2 gas. So the N2O4 gas from colorless form a pale brown color. Okay, ni mula-mula reaction dia berlaku. Okay, then the color slowly darkens, but after a few moments, no further color change can be seen. Why? Because all the N2O4 gas has completely turned form NO2 gas brown. So makin lama yang kita nampak the intensity of the brown color increases because makin lama the N2O4 gas punya concentration decreases and the concentration of NO2 gas increases in forward reaction. Okay. So macam ni lah kan. So first the colorless but then dia jadi macam ni lama-lama masa dekat C tu. Okay, first start dia macam ni. And then B mixtures become pale brown. And then sebab apa? N2O4 started to decompose to reddish brown NO2. Next mixture reach final color. Maksudnya the N2O4 completely decompose into NO2 gas. Okay, reaction they reach equilibrium at this state. Okay, now the concentration and color remain constant. Okay, remain constant sebab the both forward and reverse reaction dah sama. Okay, so color tak akan berubah-ubah dah. Okay. Alright, so at equilibrium, N2O4 molecule decompose as fast as NO2 molecules combine. So, the rate of N2O4 decompose sama dengan is equal to the rate of NO2 combine back to form N2O4. Okay? Alright. So, keep in mind that at equilibrium, the rate of forward reaction N2O4 gas to NO2 gas is equal to the rate of reverse reaction to NO2 gas to form N2O4 gas back. Okay? Alright. So, at dynamic equilibrium, the concentration of N2O4 and NO2 remain constant. But, remember that the concentration of N2O4 is not equal to the concentration of NO2. Because why? This one, dia ada coefficient 2 kat sini. Kan satu je. So, lain concentration dia kan. Kan dia cakap chemical concentration dia depends on the coefficient lah. Dia punya chemical equation. Okay. Not because the equilibrium mesti sama concentration. Tak. Concentration cuma remain constant. Maksudnya remain constant dia tak berubah-ubah. Okay. Okay. So, characteristic of a system in equilibrium. So, first, karakteristik dia, reactant and product concentration are constant over time. So, bila reactants and product concentration constant over time, we know that the reaction has reached the dynamic equilibrium. Okay, so forward reaction equals to reverse reaction. Okay, next. The third, kenapa nombor satu-satu? Patutnya 1, 2, 3 kan? Okay, tak apalah. So, third characteristic is the reaction quotient Q is equals to the equilibrium constant K. This one we will learn in the next subtopic. This one we will learn right after this. Okay. Law of chemical equilibrium, also known as law of mass action. So, it states that for a reversible reaction at equilibrium and constant temperature, a certain ratio of reactant and product concentration has a constant value K. So, K is the equilibrium constant. Or, for a particular system and temperature, the same equilibrium state is attained regardless of how the reaction is run. So, this is the law of mass action. Okay, chemical equilibrium constant. So, what is equilibrium constant? So, consider this general reaction. We have A plus B from C plus D. So, The small letter A, B, C, D is a stoichiometric coefficient for the reacting species A, B, C, and D respectively. Okay, so at equilibrium, we have K, equilibrium constant, equal to the product of the concentration of the multiplication. The multiplication, korang panggil? The multiplication, the ratio of the product over reactant. So product bahagi reactant. Okay. So apa yang awak kena buat? Awak kena kalikan, you have to multiply all the concentration of product over multiplication of all the concentration of reactant. So for example, the concentration of C to the power of coefficient, because this is the coefficient. Macam dia bagi tahu mol lah juga kan. So dekat sini, you kena buat the concentration of C to the power of small c times the concentration of D to the power of small letter d over concentration of A to the power of small letter a times the concentration of B to the power of small letter b. Okay, equals to equilibrium constant. So the square bracket shows the concentration. Okay. So for example, we have this N2O4 gas decomposed into 2NO2 gas. Okay, so start with NO2. Produk dia macam ni. Kalau kita jadikan NO2 the reactant, so with time the NO2 punya concentration will decrease and the concentration of N2O4 increase with time. Okay, kalau kita start with N2O4, the reactant N2O4 will decrease over time and the product NO2 will increase over time. Okay, and when we start with NO2 and N2O4, this will happen lah. Okay. Alright. So, even though equilibrium is reached in all cases, the equilibrium concentration of NO2 and N2O4 are not the same. The equilibrium concentration of NO2 and N2O4 are not the same. Okay. So for example, this is when the equilibrium reach for this every single reaction. Okay. Okay, dia tak tunjuk kat sini macam nak kira. Okay, let's do the equilibrium constant expression K for this reaction. Okay, so we got here. Okay, for equilibrium constant tadi saya cakap K is equals to product, concentration of product over concentration of reactant. Am I right? So this is the product, so this is the reactant. So K here is equals to concentration of product NO2 to the power of 2, because this is the coefficient, right? Stoichiometric coefficient over concentration of N2O4. So this is how you do the equilibrium constant K punya expression untuk this chemical equation. Okay, kita tengok lagi contoh kalau kita ada. Apa lagi contoh yang ada? Okay, kita tengok satu contoh yang ni. Kita buat kat sebelah, okay? Okay, contoh-contoh lagi. Kita ada satu equation. N2 gas plus 3H2 gas reversible reaction to form 2NH3 gas. So, to do the equilibrium constant expression, so K is equals to product, concentration of product over concentration of reactant. Right. So, kat sini, product dia NH3, right? So, K is equals to NH3 to the power of, kat sini ada 2 kan? To the power of 2 divide by reactant concentration of N2. Ada coefficient ke depan? Tak ada. So, biarkan je. Times dengan H2 to the power of 3. So, this is how you do the equilibrium constant K punya expression for this chemical equation. Okay, so this is the example lah. Extra example for you to understand about yang tadi ni. Macam mana nak buat equilibrium constant punya expression ni. Okay, alright. Okay, so now what you need to do is scan the QR code here, and then you have to answer 3 simple questions regarding today's lecture. And please make sure that you answer this question because this will mark your attendance. Okay, so kalau you jawab quiz ni, Miss akan anggap you hadir for this tutorial. Okay, so that's all for today. Bye-bye. Assalamualaikum. Thank you for listening. Bye-bye.